Folks, my name is Paul Gibbs. I am with Extreme Tank Technologies. I'm based here in Midland, Texas. I tell people my office is in a Dodge Ram pickup more than it is any other place. That's where I live, is in a pickup. Going from any part of Texas or Colorado or North Dakota or wherever, New Mexico, wherever I'm needed. This coronavirus has sure affected me like it has everybody else. We had to put a stop to a lot of good projects we had going, and hopefully they'll all pick back up. But give you a little bit of history about this tool. 1990 was my original patent on this tool. Since then, I've gotten numerous other patents, process patents on this tool. That I do things with this tool that makes sense and it solves a lot of problems. Anywhere from fire extinguishing, I tell people I don't fight tank fires, I put them out. Reed vapor pressure, I solved that problem. Here in the Permian, we have reed vapor pressure in the wintertime when a cold front hits. This past winter, it wasn't a bad winter, so there wasn't much problems with it. But when you're talking about distillation and gas breaking out of oil, pressure and temperature are your two main factors. I spent 25 years at the Beach Street Refinery running atmospheric distillation and vacuum distillation. So cooking oil is my wheelhouse. In 1990, when I first invented this tool, we didn't know what greenhouse gases or volatile organic compounds or melting ice glaciers, and we didn't know that methane is your worst greenhouse gas. They had most reflectant problems that there are. But as we've gone on and we've learned in this industry, I also figured out this tool when it came to distillation and capture of the hydrogen, capture of the carbon gases in a tank. This was the most efficient tool that there is. What it is, it enhances carbon capture. If you're capturing today off your tank or off of a vapor tower, and I'll tell you right now, I'm not a vapor tower fan. Stacking crude oil up at night, it's not the way to release gases. You need surface area for that. This tool enhances carbon capture. I can go into any place there is and raise your numbers by 18% or greater. In the wintertime, I'm talking 30, 40, 50, 60%. The compressor will run as long in January as it does in July, your vapor recovery compressor, even in cold climates. Because of that, I saw reed vapor pressure. What is reed vapor pressure? It's a measurement of gas tied up in liquids. For 25 years, I put reed vapor pressure in gasoline. I can remember, I'm 59 years old, and I can remember old timers talking about vapor locking engines. Personally, myself, I don't remember ever seeing a vapor locked engine. It's because back in the late 60s, they started making gasoline for the area that you lived in. Mm-hmm. All gasoline was the same. So if I shipped gasoline to Minneapolis, St. Paul, Minnesota in February, and it went up by pipeline, its reed vapor pressure was a lot higher than the gasoline that was going to Houston, Texas, because it might be -40 in Minneapolis, St. Paul, and it's going to be 60 degrees in Houston. So that gasoline in Minneapolis, St. Paul had to get to a vapor state for that engine to run a lot easier, so its RVP was higher. So I had dealt with RVP my whole adult life in a refinery, but I didn't know it existed in crude oil until a couple of years ago when these shell plays, they started turning down the crude oil. And the reason is if I sold you 100 barrels and it was high RVP, by the time you got it and went through a tank or two, it flashed off and you were only getting 90 barrels. Well, basically what that boils down to is you have unstable liquid. So the reed vapor pressure had to be solved to make that's stabilizing the liquid. This tool does that, and we'll explain that as we go into this, how we're doing that as we go. Detect and extinguish tank fires. If lightning hits a tank in less than 1 second, it will detect the flame. In less than 1 second, I've got foam. I can have an automatic system that has foam heading that way. You'll see a video of putting out a tank fire with a 1-inch hose. did it in 15 seconds. It's about where you place the foam and how you keep the foam all together for its best efficiency. And that's what this tool does. Because I'm working in the flash zone where all the action is taking place, it's also the best place to put foam. This tool will change the tank's atmosphere from flammable to inert. I can show up with a bottle of nitrogen and change that whole tank's atmosphere where it won't burn.
Mm-hmm.
This next one, removing H2S to increase the life expectancy of the tank. That's mainly talking about floating roof tanks. If you have a floating roof tank in sour service, those roofs last about 3 years, and then you have to reskin those roofs. I actually am the only person that can go in a floating roof and go underneath that roof and capture gases. There are vapor spaces where the pontoons are, and we can work in those vapor spaces. And also, when there's a fire, our first objective is to protect that seal. We're putting the foam on top of the hydrocarbon of the fuel, and we're protecting that. We're extinguishing tank fires that way. But we're also lowering the acidic atmosphere by removing the H2S's. It makes that roof last longer. And so you can go 8 years with it versus 3 years. Allows you to handle and treat bad oil. We'll talk about that. There's really no such thing as bad oil anymore. And now that, well, there is a thing that's bad oil, but there's no such thing as being locked down with that tank. Most of the producers here in the Permian Basin, they'll have 6 or 8 or 12 wells to a tank battery. If they get on bad oil, they will pretty much give that tank away just to get rid of it. I'm going to show you how this tool solves this. You don't have no longer have to do that. And because I'm solving RVP and I'm solving the problems with bad oil on capital work, you can go under 30% less tanks. Because when you design a tank battery, you design it for these problems, for storage capacity. These problems no longer exist. All right, the next one says this tool assists in keeping your oil clean during hot oiling programs. It's pretty simple. We'll talk about that when we get to some tank pictures. This tool works, yes, in crude oil tanks for carbon capture, but it also works in saltwater disposal tanks, water flood tanks, secondary recovery. I have the best skimming tool there is. I've got customers out there who send me letters thanking me for how well this tool works. I got one particular customer, his new project he built, he had 3 5,000 barrel tanks. I put a skimmer in each tank. He has a camera that looks through that tank, and at 24 inches of oil shows up on top of those tanks. A pump comes on. He pumps it down to 6 inches. Out of those 3 5,000 barrel tanks, that 1.5 foot of oil he removes from each one of those tanks fills up his 480 barrel tank. He's never treated it. He's never had to pull water off of it. It's been pipeline oil over time. That's how at the top we are and how clean of a cut we get. So you'll never have to hire a truck again to come and take the oil off your water tanks. You'll never have to worry about static charge and someone dying by sticking a rubber hose down the top of your tank. Another thing this tool does is it grounds the load inside the tank. This tool is all metal. I come to the manway door, I ground that. I have grounded the liquid load in that tank. When it comes to water, water is 5 times more of a static charge builder than what crude oil is. That's why we have so many SWDs blowing up everywhere, whether it's a lightning storm or just static electricity. North Dakota State University is doing a study on this, and they reached out to me, and we've spent hours talking on the phone. But this is a tool that grounds the static charge from building. And what else this tool can do? If you're in the business of heavy oils, 28 gravity sour crude oil stuff, you deal with a lot of iron sulfide, a lot of tank bottoms, a lot of dirt. And then in the wintertime, a lot of times tank bottoms will turn loose. It seems to be in the wintertime more so than summer. It just depends on where you're at. This tool stops tank bottoms from affecting your cell of a tank. I can sell from the very top level where I'm not pulling from the tank bottoms. This tool's been around now for 30 years. It has been tested by TCEQ. TCEQ has brought Battelle Engineering out to do a case study on it. That is your largest research engineering firm in the U.S. They're out of Columbus, Ohio. We'll talk about gas recovery here. When I tell people we get 18% gain, that is a low number if you want to add up the 365 days a year of what you're doing today. And I'm telling you right now, you're missing gases today. Everyone is missing gases. Unless you're taking the suction from the flash zone, the most volatile active air that there is, gases are condensing back on you and you're not removing them. They will flash at a later date, and if they build up enough, they finally get out of the tank. But you're never stabilizing anything. You're not stabilizing the liquid, which means your gases aren't stabilized, and vice versa. How I gain 18% is I'm grabbing the heavy molecules that everyone's missing, the things that are condensing. Your BTUs will be higher. If you're pulling off the roof of a tank right now and you go and add my tool, you will gain more gas. The gases you gain will be a higher BTU, and the reason is it's the heavier molecules that I'm capturing. It proves the point. The GC analysis from the lab proves the point. If you'll look here, let me move my. Can y'all see my mouse?
Yes, sir.
Well, that just jumped on me. All right, average BTU was 1,326 here, and average BTU is 1,186. This is the tank battery where we're using my tool on one tank, and we're coming off the roof with traditional vapor recovery on another tank. Same crude oil, same ambient temperatures, same apples to apples, everything. That is a 10% gain in BTU, and all I did was stick a tool in there and start capturing in the flash zone. And by doing that, I'm able to stabilize the vapors in that tank. I have customers today, especially in New Mexico, because New Mexico police is a lot harder. Their vapor recovery is big enough because it pumps the tanks down and it shuts off. And when it comes back on, it starts running, and then all of a sudden their thief hatches and their Nardo valves start lifting and they got gas going everywhere. That's because it's an unstable environment. They are not removing those heavy, let's say, see, picture this. I'm sitting here in this chair in my office. The floor, this room is a tank. We're sitting inside of a tank. Your floor, wherever you're at, your house or your office, that's your oil level. Gases flash out and they have to rise and get out of your ceiling to go out to a compressor. Well, C7s will get about halfway to your ceiling and they'll condense and go back to a liquid. C6s will make it to the roof, condense, go back to liquid. C5s will make it to the roof, crawl over, try to find that 4-inch opening, they'll form a droplet, falls back down, splash back into your liquid. If you don't remove those, they're still active. They will flash again later. You keep on bringing oil in, you still have more C7s, 6s, and 5s that show up. And that's what happens. Let's say that compressor comes on at 6 ounces. It hit 6 ounces, the compressor came on. Now you have these extra C7s and 5s and 6s are sitting around. They'll flash, and bam, it goes to 12 ounces. That lifts your Nardo valves, even though your compressor was running. Where your feet are right now on your floor, that's where I'm taking suction. 5 inches above the liquid level. Nothing condenses by me. Nothing, as soon as it flashes, I take it out. That stabilizes the liquids, that stabilizes the vapors. That keeps you from building up any molecule to have it flash later and affect, and it goes past what your thief hatches or your Nardo valves on your vent line are at. And it stops that nonsense. This is the traditional way here. You come off the roof, you go to the compressor. Let me give you an idea. Right before the compressor, let's say you have a pressure transmitter. I'll make up some numbers. 6 ounces, the compressor comes on, 2 ounces, it shuts off. If I was to build a trend, it comes on at 6, it pumped it down to 2, it shut off, it goes back to 6, it pumps it down to 2, it shuts off. You have these little ocean waves of 6s and 2s. I'm working in the flash zone, the most volatile active area there is. I haven't changed the thing. The compressor's still sitting there. Pressure transmitter's in the same spot. If I was to build the trend now, it looks like you hooked me up to an EKG machine on an exercise bicycle. You have all these explosions and releases and spikes. It's reading the most active area that there is. It's not having to rise 10 foot, 15 foot to get out of the tank. As soon as it flashes, I'm taking it out. Your scrubber pot will fill up more. If you have RVP issues, you do not want to pump that scrubber pot back to your tank because you're just pumping the problem back. But you can pump it back to a slop tank, let's say. Pick a tank that you're not using. If not having RVP issues, you can pump the liquids back to this original tank. But you will gather more heavier gases. You will stabilize the atmosphere. You won't be lifting your Nardo valves and your thief hatches while the compressor is running. This is a video here that gives you an idea of where we're sitting and where we're taking suction. Right now, the traditional way off the roof, you're only going to get what's pushed out and down to that compressor. Where I'm at, I'm getting everything that flashes. When I take the gas out, if it's already an existing tank better, I use a man-way door. That way we don't have to do hot work on any tank. We'll just show up with a man-way door with connections in it. Okay, let's talk about distillation here. This is a distillation column that we take crude oil up to 685 degrees. We enter the crude oil right here on the side of this tower. It comes in here. This is considered the flash zone. Any area that's in the most active area is considered the flash zone. You're on this big, say, 500 barrel tank or 1,000 barrel tank. Right above this liquid is the flash zone. That's where I'm working. So if I enter here at 685 degrees, I'm telling you right now with WTI, 37% will make it to the top. At 685 degrees Fahrenheit, I can only get 37% at the top of that tower. In this crude oil tank, you're at 120 degrees, pretty much average. Mm-hmm. Some people, oh, I got this, or I'll get 180, 80, I don't care. You're not 685. My point being, you have molecules, gas, oil, diesel, kerosene, jet, they condense before they ever get up and out of there. And that's what we call side draws. This tool takes care of your side draws and it takes care of your overhead. I capture every molecule that there is. It's a complete carbon capture. This same tool, because of where it sits, if you do have a tank fire, if your roof does not come off, a fire department can't do a dang thing about it. Watch it burn. You can run a pipe a football field away, and from a safe distance with one hose, in 30 seconds, they can have their foam enter that tank, put that tank fire out. It can be set up with an automatic system, or if it's like a tank farm, refineries, they have their own utilities there. We hook it up to their utilities. It's considered a type 1 tank fire tool. And I'll tell you that the head fire chief for Chevron USA calls this the best tank fire tool he's ever seen. This is an idea of what the tool looks like. These 4 cylinders or pipes are the floats. There's 1, 2, 3, 4 of them. The center here, yes, this can be changed in size. I did this particular one. This is a 4-inch to a 6-inch. So I have a 6-inch intake on gas going out a 4-inch, and there'll be a hose on it taking the gas out. This is also your lifeline for foam to come in, and we put the foam out right here. We're putting the foam, fire foam, on top of the liquid. There is no splash. The foam does not travel through 2,400 degree flames. The wind is not turning it off. Every gallon I send there, a gallon shows up there, and it goes in the right spot, the flash zone. This right here is my liquid, a little skimmer that sits on the side here. I can go in or out with this tool. If I'm in Williamston, North Dakota, and it's negative 35 degrees this morning, and I can't get the gas to break out and have a high RVP, I'm going to use this line right here as my fill line for this tank. That way my 120 degree oil, my heater treater, is releasing at the surface at 120 degrees. This yellow line right here represents that. That will be my fill line. And when I release 120 degree oil, it's going to do what 120 degree oil does, and that's flash and get rid of that gas. Right now, what everyone does is they come in on your traditional line and they come down and it releases down at the bottom. Well, for every foot, you pretty much count it as a half pound of head pressure. So if I've got 10 foot of oil and I come in at 120 degrees and it's hitting 60 degree oil, that tank's 60 degrees, it's condensing. And also I have 5 pounds of pressure on it. It's not going to release gas. But I can come in and use this skimming line as a fill line of my tank, and I never break static. And which, by the way, I want to talk about that. I've got customers, it was real bad about 3 years ago. They were cutting the inlet here and just letting this oil fly in here, and it was helping with RVP. Yeah, it breaks the gas out great. That is the engineering standard that you're taking and tearing up and throwing away. This line must be touching liquid even after the tank is sewed. That's why you have 10 inches in the bottom of the tank once it's sewed, is to keep everything grounded. So if I release any liquid here from this point until it splashes, you're building a static charge. It's not a matter of if you're going to catch on fire, it's a matter of when you're going to catch on fire, when your oxygen is right, because you're making static. I used to take a 175-pound steam drop, put a hose on it, with a good pair of gloves, stick my hand out there past the steam, and it would make sparks like a sparkler that you get for 4th of July. And that's all. What is steam? It's swelled water. It's funny how I can make sparks from water, but that is because from the point it's released to the point it hit my hand, it's picking up protons and neutrons, and it's building up a charge. If you use my tool here, that's another thing. This tool is all metal. It stops the static build from this liquid. I'm releasing it in liquid. I'm not releasing it above the liquid. I'm releasing it at the surface. And I'm letting hot oil do what it does, and that's break out. So this is a safe way, and it's a way that even in cold weather, Alaska, North Dakota, Utah, Montana, Pennsylvania, Ohio, those places where it's not as warm in the summertime as we have it here. We have Christmases here that can be 75 degrees. This is a way to solve re-vapor pressure issues. Also, I want to talk about, we talked about hot oiling, how we can help in the hot oiling program. A hot oiler will show up, and he'll go to your tank, and he'll get 90 barrels from your sales line. Your sales line's 10 inches from the bottom here. And at any moment, tank bottles can turn loose and come on his truck, and he goes to well number 1, and he heats it up, and he pumps it down the casing, and it melts the paraffin scale on the casing and the production tubing and the flow line. Well, here it all comes right back, and it goes right in here, and it dumps, releases right there. Now you have all these floating particles in the bottom of this tank floating around. He comes back to get the second load to go to well number 2. What he's getting is trash that he just spread out of well number 1. He's going to take it, he's going to pump it down well number 2. So, as you see, the more wells he does, the more concentrated the trash shows up here. And what he's doing is damaging these wells. Well, we've drilled these horizontal wells. We spent $16 million doing it, and we're pumping trash down them. Or what you could do, you could never use this sales line again. Suck from the skimming line. So if you have 12 foot in your tank, or 14 foot, or 8 foot, whatever it is, you're not 10 inches. You're getting the cleanest oil that there is. And you can fill up this truck from this point, the top level. And you never have to worry about damaging your wells again with a hot oiling program.
Hey, Paul.
Yes, sir.
I got a quick question.
Yes, sir.
I may have missed it when I was bouncing in and out, but how is this installed in a full tank?
That manway right there. If it's an existing tank, we'll go to that manway.
Okay.
We show up generally with a new manual with couplings welded on it. That way you don't have to do hot work.
That's what I was wondering, if there was any hot work involved.
There's no hot work. And we set the tool in the tank, both up inside the door, both the door up, put valves on it. You have your tank back. You can spend a month hooking up pumps and compressors and whatever, fire systems, whatever you wanted to, but you can have your tank back in a half a day.
Yeah. Okay. Cool.
All right. That was the holiday. Let's talk about bad oil. Picture this tank completely full. Let's say it's a 24-foot tall tank, completely full. I'm on bad oil. Like I said, out here in the Permian, where we have numerous wells going to tank battery, they will give the oil away, or they'll sell it 20 cents on the barrel. I have a lot of buddies of mine who are trucking managers, and they went and bought 2 acres somewhere and put in 10 tanks that they don't have registered with nobody, and they will buy that oil for 20 cents on the dollar. And they'll take their trucks, they get paid for it, and they truck it to their slop oil tanks and let it sit for a day or two, and then have 98% oil and 2% water. And it sits there long enough. But no one, because of the volumes coming in nowadays of 30,000 barrels a day, or 60,000 barrels a day, or 18,000 barrels a day, no one wants the problem of bad oil. Well, here's the deal. Bad oil, 98% of the time, is going to be emulsions, water tied up. Your sales line is 10 inches from the bottom of the tank. That's where it hangs out. That's where your water is. If this tank is completely full, I can turn on a pump and I can suck from the top level. I can suck from 24 foot up there. That's where I'm taking suction at. I can suck that tank all the way down, let's say, to 4 foot. That's where I'm hitting real bad, the actual bad oil. I've removed 20 foot of oil and I've sold it for market price. I didn't give it away. What else I've done is I removed 20 foot of oil that was going to absorb my chemical shock. From outside the tank, I come in here and I use a skimming line that I just sucked it out with, and I inject chemical in. Well, my computer is locked up. I'm going to release chemical and let the chemical go out across the tank, fall through the liquid, because I'm releasing at the top of the surface, and it'll grab a hold of the water and weigh it out and knock out the water in an hour's time. This allows me to think of bad oil as not nothing more but just an hour or two problem. Rhonda. Anyway, I had to step away for a second. My computer is locked up here. I don't know why it's not. I'm trying to call my. Second, guys, we're trying to figure out what happened here. Give me a second here. We got technical difficulties.
Gotta love technology.
It just locked up. I don't know what it won't back out. It won't do anything.
There it goes.
Right. There it goes. All right.
See right here, just choose that.
Okay. All right.
Had to call IT in, huh?
Yes. She's got 2 master's degrees in technology, and I'm left-handed with this thing, so there's a big difference. All right. So use those arrows. Let me get back. So when I release the chemical, I can release it at the surface there and let it fall through it. So when it comes now, you don't have to deal with RVP. That oil is really not a problem. I tell people, especially nowadays, everyone's trying to cut money like crazy. You can go with 30% less tankage. You don't need 10 1,000 barrel tanks. You need 7, because those problems are very manageable now. When it comes to 2-phase, that this skimmer that you saw inside the tool, I also build it where I just build just a plain skimmer. You can see here, these are big 4-inch skimmers. This guy way overdid it. This thing will pump 5,000 or 6,000 barrels a day, and he had a 900 barrel a day pump. But these things stay in your tank. They ground your load. They remove your oil from the water tanks. You never hire a truck again. You use your pump. You put it back to your oil tank. They're money makers, and they're a simple idea, and they work all day long. This tool, I can take a bottle of nitrogen and purge that tank, or if you have a nitrogen drop, you're in a plant, you change the tank's atmosphere, you lower the lower explosion level low enough, you never have a fire or have a chance of explosion. So if you have a crew up there banging around on the tank with hammers and stuff, and you're getting worried, you can purge that tank from the right spot. I have people tell me all the time, well, we purge our tanks, and I show up and they have a hose stuck at the top of their tank. If you're not releasing nitrogen at the root cause of the liquid level, you are not purging anything. We'll talk about big tanks, your floating roof tanks. This is one of the good old earthworks. This is the people who go out and take video of everybody and make us all look bad. But this is in the Delaware Basin. There's a reason I show this. This is in the Delaware Basin, which is not that old of a field. These are big tanks, 10 or 15 years, probably no more than 10 years old. And it just shows you the amount of gas that leaks around the seal of a tank. The reason I show this is because I can work underneath these roofs. I can capture. If I capture, it doesn't leak. This next tank here looks like a thunderstorm coming in. Yeah, this one here. That is a lot of money going in the atmosphere. We could take this gas, we can use a gas turbine engine, we can make electricity with it. You can sell it. You can do a lot of things with it. You can it changes your permitting, people. In a non-attainment area of Texas, they're charging $350,000 per metric ton to permit those tanks. That $350,000 per metric ton is on emissions. Well, if you capture those emissions, that goes away. On tank batteries, I have customers, and it's been around since mankind, since vapor recovery came around. O2 issues, thief hatches leaking. Like I said earlier, this tool stabilizes the atmosphere. It does not allow any buildup of C whatever, C7s, C6s to keep on getting larger on your flashes and lifting your Nardo valves and lifting your thief hatches and making them vent even when the compressor's running. I see that all the time. I have every oil company I've talked to has got that problem. And it's because it's not a stable atmosphere. This tool's stable. But the old traditional way of blowing from the roof, like it's showing here, when you have a thief hatch that leaks in, all that is a direct line to that compressor, which is a direct line to that gas meter, and it says 5%, 8%, whatever it shuts you off at. Wham, it shuts you off, and they'll come out in about 10 days and open it back up. You can be out of compliance for 10 days. And I'm not about to sit here and say that I solve all O2 issues. That is not my point. My point is I am taking suction 5 inches above where you're putting every barrel of oil in. It's constantly getting fed methane, pentane, propanes, all those gases. It is hard to get O2, and it's going to take a while. How about that? It's going to take a while to get O2 to that area. It might give it time for that thief hatch to reseat itself, and you never know what happened versus it shutting down. Now on floating roofs, I'll run through it right quick. This gives you an idea. I go underneath the roof. I work it this way. Generally, I'm going to be at the sill area. This guy just did this CAD drawing, put it in the center. It depends on how the roof is built, where your pontoons are. That's the area I'll be hanging out. Main objective is to protect that sill during a fire. We We do, like I said, we're not in the tank firefighting business. We're in the tank fire extinguishing business. There are applications for this tool and processes like refineries. This would be fluidic cat cracking unit charge tank. This is 18 gravity oil. On the books, it doesn't show any emissions at all because everything's based off 60 degrees Fahrenheit, but that oil's at 375 and it's emitting like crazy. You can actually take a draw and be drawing gas off this tank and use O2 sensors to speed it up, slow it down, or shut it off once O2 shows up. You could actually go into a tanks like this and start capturing 90% versus no one captures at all in these tanks because of all the vents on top. Let's talk about fire technology a little bit here. We used a fiberglass tank. We're burning diesel and gasoline fuel. The winds were blowing about 30 miles an hour. We used a 60-gallon CAF system, compressed air foam system. That's what CAF stands for. You see this tool, the black floats are stainless. They're just painted black to hide the grind marks. This red hose at the bottom of the tank, that's a 1-inch hose. I will put this tank fire out with a 1-inch hose. We let this tank get fully engulfed before we do anything. We had 2 cameras, I believe, on this. I was on 1 camera on a ladder, and my video was no good because it got so stinking hot that I had to move, and then when the foam hit, it got hotter in a hurry. But we let this tank get fully engulfed, and by the way, fiberglass tanks, they don't expand. They just pop and crack, and I thought this tank was going to come apart on me. You'll see some red letters pop up. That marks when we open a 1-inch valve for foam to start. All right, the foam just started on a 1-inch line. I'm going to put out a tank fire with a 1-inch hose. Every gallon I sent shows up there. Every gallon that's sent, there's no splash. Hydrocarbons not getting splashed out of the tank, up against the wall of the tank. The foam stays tied together better than any application that there is. The wind is not carrying it off. If I'd have been a fireman out here with a hose, with a crosswind and 30-mile-an-hour wind would have carried 30% of the foam away. It's like I said, it's what many in the industry, many leaders in the industry call the best fire tool they've seen yet on a tank. This tool is an environmental tool, but you can use it as a fire tool. A fire truck can show up and put out your tank battery fire or your large tank fire in a matter of no time. On-site utilities, if it's a tank farm or a refinery, they tie on this tool. Fire trucks can use it, and CAF systems, an automatic system. I'll show you this video here. This is just a cool video. You'll notice before I start it, there's 1 tank on fire. That roof is still on that tank. I think the roof is damaged, but the roof is still on that tank. What's going to happen is the heat from this fire is making the other surrounding tanks get hot, and the gases start getting more volatile, more active, and start breaking out like crazy. I believe there's 5 streams of water going here. Leaf hatch just give. Gas came out, it ignited. There was a static spark or embers or whatever lit this other tank. The only reason these firemen are alive today is luck. That's all I can say. It should have, could have killed everybody. This tank here that are designed, as we all know, to rip the roof off whenever there's a problem. You're fixing to see here that API or ANSI standards don't always play out right. My point is this video, if the extreme tank technology tool would have been in there from a football field away, not up against these tanks, like they're parked right now, they could have put this tank fire out in 60 seconds. The other tanks would not have caught on fire. This would not have been a domino effect. Everyone was fine. Like I said, I don't know how they all, because the air they're breathing became 1,500 degrees Fahrenheit just in a matter of a microsecond. The wind was right. They turned and ran right. There was enough obstruction in the way to keep the heat just enough off of them. I believe it was 19 tanks there that they lost, a total of. This next one, you'll see the roof come off. It actually works right. There's not a feeling in the world than sitting there watching your tanks burn, and there's nothing you can do about it. I mean, and that's a nice fire truck. They got snorkels and they got some nice equipment. But all they needed, if my tool would have been in there, would have been a one inch and a half hose. They could have tied on an 1.5 inch pipe that went to the back side of that tank and put that foam in there. A fire truck from a safe distance can go home successful and safe every day. Because when they pump it, it's going to wind up releasing it internally inside that tank. It can be set up with an automatic system. This green camera here is the camera that you can use it for your tank levels and all that, but it's going to detect heat, it's going to detect flame. You can have stored fire foam, and it can be signaled from that camera. A solenoid opens a valve and foam goes into your tank. So what this tool does in the environmental world, it solves environmental problems. It's the best carbon capture tool that there is. There's nothing that can outdo it. I can go in there and outdo whatever anybody's got. I can work on floating roof tanks. I can lower the corrosion on that roof if it's a fire service.
Hey, Paul,
Yes, sir.
is this a one-use, your tank there, is that a one-use shot and then it needs recharging, or how does that work?
On the fire system?
Yes.
Picture this, it's like a propane tank sitting outside your tank. It's a pressurized tank, it's full of foam. If it's used, you go back and fill it back up.
Okay.
And you use it over and over again.
Right. All right. Thank you.
It increases your BTUs and the volume of gases, because I'm capturing gases. Like I said, everyone's missing today. That's how I can go on there and tell you right now, I can capture more gases, because everyone's missing it. Just the laws of physics, that's the way it is. It helps alleviate a lot of O2 issues. I'm not about to sit here and say, man, I'll solve O2, because there's O2 issues all the time out in the field. Revapor pressure, that goes away, even in cold weather. I have customers that are able to get rid of a lot of expensive rental equipment that they were trying to raise the temperature up so much. And that's what distillation's about, pressure and temperature. But they were trying to get 180 degrees, because the volume of oil they had coming in is what they needed to reach to get the gases cooked off. Well, because of where we're releasing it, we don't have static head pressure, and we're not cooling it off by taking 180 degree oil and putting it in a 75 degree oil tank. We're letting it release at the surface, and let the gases break out. They are able to turn loose a lot of the expensive rental inline heaters and stuff that they have. This tool will allow you to, what I call, sell bad oil. Give me a bad oil tank, you can't sell it because you're pulling from the bottom of the tank. I can with this tool. I'm pulling from the top. I can pull it down to where the actual bad oil lies. And at that point, I can treat it in a hurry, because all I have left is a minimum amount, 4 foot, 3 foot, 2 foot, whatever it is. It allows you to treat your bad oil correctly. Allows you to tank space to continue oil production. That's another thing, is even when I remove that 20 foot of bad oil and I have 4 foot of 20 foot of good oil, I have 4 foot of bad oil left behind, I still got 20 foot of space. That's, to me as a producer, that's what I'm worried about, is space. It keeps your hauling schedule clean. There is no more worries of taking chances of pumping trash down a well. And that's what amazes me, is we spend so much time and money and effort on these wells, and yet we let things like that, the little things, get away from us. Detect and extinguish tank fires. We can do it in less than a second. Fire department can use this tool. Like I said, from a safe distance, they don't have to pull up the tank batteries no more. Around my part of the world, a lot of these volunteer fire departments have come out and said, hey, we're here for the brush fire. We're not here for the, and everybody just watches their tank burn. And I'll get a lot of answers like, well, we got it insured. The average cost for bioremediation cleanup of the dirt on an SWD is $650,000. That's not the tanks, the wiring, the motors, the pumps, the electrical, that's to clean the dirt. You can insure that. You can insure your tanks and your production loss and things like that. But oil or water, either one, with the chlorides they got, put them on out in the ground is where it gets expensive. Change your tank's atmosphere from flammable to inert. I have not done this yet, but I am talking to a SWD company about getting a small nitrogen skid that takes air from the atmosphere, makes nitrogen, and putting the nitrogen in the SWD tanks and sweeping the tanks. That's a thought that people are running by right now. Produced water tanks, we keep the oil off. That also helps you if there's a tank fire. It's hard to burn water. It's pretty easy to burn oil. If your oil is off your tanks, this will help you out tremendously. Grounds the load inside your tank. The liquid load inside that tank is grounded. There's no static buildup because I have a metal object running through it, stainless steel or carbon steel, and I am going to ground it when it comes to that manway door. Stabilize the tank bottoms. Like I said before, if you have heavy oil that you're dealing with, secondary recovery, you have a lot of iron sulfides. I cut my teeth in the field like that. Water injection like crazy. The tank bottoms were a big deal. And every now and then the tank bottoms would turn loose and fail you, and the LAC unit was shut down or the truck driver wouldn't take it. This tool right here stops that because now I can suck them up in the air away from those tank bottoms. This can buy you time, a month or two, until you want to go in and actually clean out your tank bottoms. I actually have a customer with SWD who also takes in solids. He was having to turn down flowbacks because he had to go in and clean his tanks. Once my tool was put in there, it bought him a month or two where he was able to take a flowback or two and make him $1 million on a bunch of oil coming to him. And it was worth it because he didn't have to use this suction on his tank or his discharge into his tank. He could use this tool, and it all worked off the top.
Freedom?
You'd ask the question, this gives you an idea. Let me start right here. Manway, we show up the new manway, stick the tool in, you see the hose is tied onto it. Bolt the door up, put valves on it, and then you can have the tank start producing right back into the tank. And then this right here, this 4-inch coming out here is the vapor going to the compressor. If you was to drop a T down the ground here and run it the other side of the location, is where the fire truck would show up and tie on. It would come right in here. This skimmer, liquid in. Like I said, I got customers, they open that up and they just leave it open year round. They don't want to mess with it. It's, why mess with something good? They use this tool to fill their tanks with. This is a picture of it going to the compressor. The compressor, of course, putting in gas cells line. Any more questions, gentlemen?
Oh, can you use halon instead of foam?
Could you use halon? I guess you could. To me, when I put foam in, once it hits, it spreads all the way across the tank. I don't know if halon's going to rise and not get over to the corner of that tank or not. I've never done a test with halon, but yeah, halon's inert. So should it work? Yes, but I have no test of that.
Okay.
You know, halon or nitrogen, either one would be an inert gas. You know, I've used inert gas nitrogen to change the atmosphere of the tank to keep it from burning or catching on fire. But the halon should put it out. But like I said, I have no fire test of that. But common sense would tell you, yes, it should. There's even.
I don't have anything else. It's a good presentation.
Thanks. There's even, I don't know if any of y'all deal with a rental equipment or anything like frac tanks or stuff. Around here, about every 3 months, a set of frac tanks catches on fire during the flowback. They'll have 5 frac tanks lined up and a truck space and 5 more lined up and trucks pulling there, and they're just taking liquid off like crazy. If you were to add this tool into a frac tank, this gives you an idea. I make any tank a 3-phase separator. I'm able to remove the gas. I'm able to remove the oil. I'm able to remove the water. Well, what's happening is it's so gassy coming off these tanks that the 18-wheelers, the diesel trucks, or the intake is taking the natural gas in and it catches the truck on fire. You can't turn the engine off. It's running off natural gas on its own. And so it burns down 10 frac tanks and an 18-wheeler and a water and a trailer, and someone minor might not get hurt. If you were to add this tool, I was setting up with a customer who was in the frac tank business to do this right when the coronavirus hit. Of course, his business went to nothing. We can remove the gases off these tanks and put it out to a 30-foot vent pipe. That way, when the truck pulls in there, there's no chance of gas coming in the intake of the truck. But here's the great point. He could go to that customer, you pick one, Pioneer, let's say, and say, if you use my frac tanks, not only will I keep your area safe, which no one's doing right now, but I'll make you so much money on your oil, you'll pay for your trucking cost. Because right now they're getting rid of all the liquid in that tank and going to SWD. But with my tool in there, they can differentiate the oil from the water, and they can take that oil out of that frac tank and give it back to Pioneer. All Pioneer has to do is tell them where to put it. And a lot of these places, they're getting about 40% of their oil when they say they're giving the oil back. But with this tool in here, you can get the cut down to 99%. And so that's a way to look at it. My tool makes any tank a 3-phase separator when it comes to the environmental side. Anyway, any more questions, you can email me. You got my email here, my phone number. That's my cell number.
I do have one more question. I'm sorry.
Sure.
How is the compressor plumbed with natural gas, or is it a dual fuel option, or are there different fuel options for it?
The compressor, as far as the mechanical goes, most around here are electrical.
Okay.
But yeah, you can get the natural gas or it just depends on what. I'm not in the compressor business. I'm in the part of solving the problems inside that tank. But most of the compressors around here are electrical motors.
Right. Okay.
I do know some out there that are, especially up in Colorado. I got a buddy of mine who works for, I've gone blank, but it's a compressor he has. It runs off natural gas.
Yeah.
He's doing quite well with that. He's got a lot of them out there and they're doing a lot of good with it.
All right. Thank you.
Anyway, feel free to call me, email me. That's all my contact information there. I can help you out on emissions. I solve problems with emissions. I can tell you that.
Our situation here in East Texas, we've got we got a pretty big network of SWD gathering lines. Residual H2S coming into our facilities basically accumulates in the tanks.
That's because it's a heavy gas. It accumulates. You're right. It accumulates those tanks.
And we don't have any compression or any kind of VRUs or anything to recover it. So it's kind of a hazard for personnel.
You are at least draw it off and put out a vent pipe up there 40, 50 foot, to get it Kinda
Well, I
like-
mean, we do that, but what I'm saying is when you get up on top of the tanks and
Oh, yeah. Oh, yeah.
your exposure is,
Yeah.
um,
Do that.
between that and we've got a lot of, we produce a lot of sand when we, flow these back, and we end up with some, sand emulsion pads and that kind of thing. So I can see where there's some uses for this thing.
You're talking about H2S. I have a customer. This is a good while back. WTI, horizontal wells out here in the Midland Basin.
Mm-hmm.
The gas he was selling off his lease, off the tanks and off the 2 and 3 phase separator, all going accumulated the gas sales line. It's going to a gas plant, and about every 3 months, it would shut him off on high H2S. Well, they'd go and check the gas. It's not high. It's sweet gas. Everybody can have a beard out there. But what they didn't take into account, and they finally figured it out, it was coming from his tanks. H2S is your heavy. There is some H2S in this gas, and it's the heaviest. So it was building up and building up and building up. Like I mentioned, the C7s and the C6s that build up, and they never leave your tank. You keep on coming, and then finally they swell up, and it overrides your Nardo valves because you put too much pressure. You have an unstable atmosphere. It built up enough, it burped out of the tank, and it might have just been 20 seconds, went across that meter, but all it needed was 2, shut them off. He said they changed out H2S sensors like 6 times, like, man, what is the deal? And they started catching bombs off the tank and sample bombs. And they got this company out there that would catch it every 5 minutes. It'd catch it, and it'd give them a number. Well, it just happened to catch it about the time that's what it was. It was H2S, and it's the heaviest gas, and it built up in his tank. And finally, they're like, "There's the problem." Well, guess what? My tool is in there now. It doesn't build up. It's not a problem no more. And that's the only customer I've had that problem. And of course, like you said, leave it to him. He's the one that has to go spend money on H2S in a sweet field.